5 minutes. Jumpstart your dreams now.
My name is Martin. We are doing the electricity-free cooling technology incubated by CTU Hong Kong Tech 300 program. And this is our Earth. We receive a lot of energy from the solar every day. And if we can have a method to reflect the solar energy, and in the meanwhile, we can emit the internal thermal energy of the Earth out to the universe, we can cool the surface and mitigate the global warming and the climate change effect. In the Sahara Desert, there is a silver ant that can survive in a super hot environment because of the self-cooling skin on the structure. And got inspired by this animal, we developed a material that can not only reflect the visible light, but can also reflect the UV and the infrared. And in the meanwhile, we can convert the internal thermal energy of the building or equipment and emit as 8 to 13 micron wavelength. And this wavelength can actually pass through the atmosphere and be absorbed by the cold universe. That's why we can generate the cooling power on the surface without any electricity. And our team, not only me, but also my professor, PhD supervisor, Dr. Erin Cho, and the VP in PolyU, Professor Chow, are our co-founding team. And we have a few investors, including Professor Li Zhexiang, who joined our board members this month. And in a real application, our material can reduce the surface temperature by more than 40 degrees C, reducing 10 degrees C indoor air temperature and save 42% of the energy consumption for AC system. And we also apply in a relatively large scale in Guangzhou to verify that our material can be used in a larger scale without the potential problems. And actually, not only the buildings, we can also apply our material on the backside and the metal framework of the solar panel to improve the generation efficiency because we can reduce the silicon-based material temperature and improve the performance. And we can also apply to some logistics supply chain and for some container for chemical or food storage to improve the storage condition. And we can also apply to some outdoor equipment, for example, sheet water pipe and condensing water pipe cooling tower to improve the equipment efficiency with a reduced surface temperature. Over the past 1 year, we have done more than 50 projects in Hong Kong, and our cooling performance has been well verified. And this is the ceremony we held last month to celebrate our first anniversary about our achievement in the global reduction in the global market. And we also can launch a B2C market by combining our cooling material into some more polymers. For example, textile, we can launch the product of the cooling umbrella and the cooling tent and some more different product. And in the recent weeks, we have achieved a collaboration in the UAE in the Middle East. There is a World Family in Abu Dhabi has tested our material with the comparison between other good cooling material, and they confirmed that our material can achieve the best performance among different competitors, and they decided to do our distributor in the GCC area with a very good potential in solving their heat gain problem. And we will also have a very big demo project with Ema Properties, one of the largest developers in Dubai, and this summer by applying our material on top of the Dubai Mall. And this is our global roadmap. We have achieved many different distribution channels in Southeast Asia, Middle East, South Africa, and even the Europe and North America. And in the future, we will combine our cooling technology into other different substrates. For example, we can put our core cooling nanoparticles into the car paint so that we can apply the material on the surface of the vehicles to reduce the heat gain and reduce the energy consumption for the vehicles, and then we can extend their driving miles. We are now collaborating with 2 manufacturers in mainland China to realize the commercialization of this concept. And in the meanwhile, we can add these cooling particles into some other substrate. For example, ceramic. We can make the reflectivity and emissivity of the ceramic to be higher than 99%, so that the cooling performance can be achieved in this material. And this is under R&D stage, and we are now collaborating with some manufacturers in the Greater Bay Area to commercialize the cooling ceramic. And we can also make this material to be thermochromic. For example, it can change the color subject to the ambient temperature, because we also want to use our technology in some northern part of the Earth so that we need the warming function in winter. And in this technology, we can become dark color in winter to absorb the solar sunlight to keep the house warm. And in winter and in summer, it changes back to the white automatically to keep the surface cool. In the future, we hope we can collaborate with different parties to promote carbon neutrality globally. Thank you.
Time is up. Thank you. And we now open the floor to the judges for questions.
I would like to keep the PowerPoint during the Q&A. Thank you.
Hi, Martin. Hi, this is Wesley from Convolve Ventures. This is very interesting. Our Motor Group has a few manufacturing sites, and actually air conditioning is a huge portion of the cost basis, so we would like to explore something like that. Just curious, where are your materials manufactured, because it was not mentioned, and also we'd like to know a little bit more about your unit economics.
Actually our manufacturing center is in Guangzhou. We rent a 20,000 square meter small factory in Guangzhou, and we can achieve 3,000 tons productivity each year. And in the future, if we want to develop some new more product manufacturing, I mean the large scale production, for example, the textile and the ceramic, we will need to collaborate with a few more different partners in manufacturing, or we need to build some self-production center in the future. So that now we are actually doing the next round of fundraising to extend our manufacturing and make our QC process better.
Hi, it's a fantastic product, and it's quite impressive, the energy savings. What are some of the challenges that you face during some deployments?
For the challenges that at the beginning, we need to consider the requirement of the market. For example, the building may not need white coating. The white color will be the best for the reflection. So that in our development, we try to use some new method to regulate the visible light absorption, but we can just reflect the UV and the near infrared. So that we can, in the second generation of our material, we do different colors. And also for the for the northern part of the Earth, as I mentioned, we do the thermochromic properties to solve the issues of the warming requirement in winter. So that we major are the technology side of the challenges. We can do more new R&D to solve these challenges.
This is Peter Look from Angels Investment Foundations. Please tell us about your financing status and what's your expectation in this round of financing. Can you tell me about it?
We have completed 2 rounds of fundraising around 20 billion Hong Kong dollars, and now we expect we can gain the revenue of around 20 million Hong Kong dollars this year, because at the moment in Hong Kong market, we have already gained more than 6 million Hong Kong dollars. So that including the Chinese market and the global market, we hope to achieve 20 million Hong Kong dollars this year. And for this round of fundraising, we hope to complete before the Mid-Autumn Festival around October or September. We hope to raise around 50 to 100 million Hong Kong dollars to extend our manufacturing and also to promote our material in the global market.
Hello, this is Andy. May I know how long the plane can last before we pay?
At the moment, we do the standard based on the building requirement. It will last around 5 to 10 years. But if we want to extend the durability, we just add our cooling particles into different kinds of water-based or oil-based emulsion. For example, if your equipment needs the durability to be 20 years, we can mix with that kind of emulsion to extend the durability.
Oh, time's up. Thank you. Thank you so much.